In this video, we are going to understand the concept of neural network. A neural network is like a web of tiny decision makers, like the mini brains, that learn from what? Data. It's just like the way the human brain functions, We can settle down to think of past event and try to make decision based on that past what? Event. So in this case, we are going to be considering the multilayer perceptron, which is the machine learning algorithm for neural networks. So we have other advanced ones like the CNN, the RNN, the LSTM. Those ones are advanced under the deep learning. So unlike other algorithms, this multilayer perceptron less complex pattern deeply, not just the rule. It is great for tough tasks like image, speech, or fraud detection. Okay, so I've loaded in all the modules that is needed, and you can see I'm using the multi-layer perceptron classifier from neural network. Now the reason why I'm choosing the classifier is because the data set we're going to be considering is a classification data set. So we're going to be using the drug data set. So let's load in the drug data set. We want to classify the drug based on the features to predict the drug type. So we say df equals to pd dot read underscore csv. We say drug 200 dot csv. So cdf dot head. So this is the data. So let's check for missing value. Say df dot is null dot sum. So there's no missing value. So let's check if our class is balanced. So say df the column of drug, which is our target variable, dot value underscore count. Now you can see the class is not balanced. So, and I made mention in the binary and multi-classification video that once the class, target class and classification tags is not balanced, the accuracy is going to be low. Why? Because it's going to learn well of one class compared to the other one. So that's why there's an advocate that, every class in classification must be balanced. If not fully balanced together, but at least the difference should not be much. Okay, so in this case, we are going to balance off our what? Our data. Okay, so we say from sklearn dot utils but the sample. So let's separate the data. So we say y equals to df the column of drug equals to drug y, x equals to df the column of drug equals to drug x. So I do the same thing for ABC. A, B, C. A, B, and C. Drug A, drug B, drug C. So let's balance off the. So we say x underscore sample equals to resample from x. The numbers of samples now is going to be 91. So I'm going to do the same thing for ABC2. So like I said, I'm going to do for ABC2. So I'm going to copy this. A, B, and C. So I'm going to change the keyword A, B, C. And I'm going to change it here also. A, B, and C. So let's join them together. So we'll say df equals to pd dot concat. Then we'll say y. Then we'll say x underscore sum A underscore sum B underscore sum, then C underscore sample. So let's reshuffle it. So see df equals to df dot sample, then we'll say fraction equals to 1, then ignore index equals to true. So let's check if it has been balanced. So we'll say df, the column of drug, dot value underscore what? Count. What do we have? Okay, let me run from. Okay, so everything is balanced now. Okay, so what I just did is there's a little error there. I just run all from the beginning again to clear the error. So we convert all the categorical column to numerical. Don't forget we said machine learning algorithm does not understand characters, it only understands numbers, numeric. So that's why we are converting all the categorical columns to what? To number. So we say cat underscore code equals to df dot select underscore d types include object, any data type that is object, and any data type that is category. Then we say encoder. Let's activate our encoder, which is label what? Encoder. Then we say for x in at. Then we say df x equals to encoder dot fit underscore transform df x. Then we say df dot head. Oh, df, not dg. Okay, so we are good to go. So let's separate the independent variable from the dependent variable. Like we said, the drug is the target variable, which is the dependent variable. So we say let x be the dependent variable. Drug and axis equals to 1. Let y be the dependent variable, which will now hold the column of what? Drug. Then let's split our data into train dataset and test dataset. We can use all the whole dataset to train and test, but the reason why we said we should have some portion for training and testing is so that we can evaluate how well the model has performed before it can be recommended for what? Deployment. So say x train, x test, y train, and y test equals to train test split from x and y. Let the test size be 0.15, which is 15%. So the splitting is ready. So let's build the multilayer perceptron model. So we say model equals to MPL classifier. Then let's say model dot fit x train and y train. Now, I told us that each algorithm have their own parameters that makes them function properly. So for the multilayer perceptron, these are the what? Parameters that make them function properly. So you should pay attention to anyone concerning maybe one of the parameter did not, its value, the default value did not perform better. If it not perform better, then you can now change it so that everything is converged. Then we can now evaluate the model. So let's try this first. Everything default. You can see there's a warning that says what? Okay, our maximum iteration 200 did not what? Converge. So let's increase the maximum iteration. So let me say I increase the maximum iteration to like 2000. Let's see. Okay, so you see this one converge properly. So let's evaluate and let's see the outcome. So we say predict equals to model not predict X test. They'll say print classification report of Y test and predict. So I'm going to do the same thing for accuracy, precision, recall, F1 score. So accuracy score, recall score. Then for the recall score, I'm going to weigh the average since the target class is multi. So I'm going to say average is weighted. So I'm going to do the same thing for the other two, which is the precision and the F1 score. Then CM equal to, which is the confusion matrix of Y test and what? Predict. So SNS dot heatmap of CM anode equals to the FMT equals 0.5 G, meaning formatting 5 decimal place. So you can see the outcome. So you can see we have 99% accuracy, all true. So this multiplier percent will perform better and it is ready for what? For deployment. So we see in our next video.